In this video, we're going to review some of the basics of polynomials. So the first thing we need to discuss is how do you name vocabulary for polynomials and how do you classify polynomials. So when we are classifying polynomials, we classify them by the number of terms that they have and by the degree. So if a polynomial has one term, we call it a monomial. If a polynomial has two terms, we call it a binomial. And if a polynomial has three terms, we call it a trinomial. Anything that's more than three, we just call a polynomial, so it doesn't get a fancy name. So if you have 4 terms or 5 terms, so on and so forth, you just call it a polynomial. Your degree is the highest exponent. And so if you don't have any variables, then you have a constant polynomial. If you have a degree of 1, you have a linear. If you have a degree of 2, you have a quadratic. If you have a degree of 3, you have a cubic. 4 is a quartic, and 5 is a quintic. Terms are the individual pieces that make up a polynomial, and terms are separated by addition and subtraction signs. So if we're looking at number 1, 1/2 x squared plus 14x plus 3 has 3 distinct pieces. It has the 1/2 x squared, it has the 14x, and it has the 3. So this has 3 terms. We would call this a trinomial. All right, when we're looking at degree is the highest exponent if there's only one variable. And so in number 2, it says the degree of 3x squared plus x. So if you notice, we've got one variable, and that variable is x. We have an x squared, and we have an x to the first. So our highest exponent on that variable of x is a 2. So our degree is 2, and we would call this a quadratic. Now we can also call this a quadratic binomial because it only has 2 pieces. It has the 3x squared and it has the x. All right, so to go back, if we have a constant, that would be like if we had the number 5. We have no variables, therefore we have no degree. A linear would be like if we had 5x to the first. A quadratic would be like if we had 5x squared. A cubic would be if we had 5x cubed. A quartic, 5x to the 4th. And a quintic, 5x to the 5th. If there is more than one variable, then you're going to add the exponents on those variables. So for example, the degree of xy to the 5th would be 6. And so the reason it would be 6 is because we've got an exponent of 5 on the y, and we have an exponent of 1 on the x. So when we add 1 plus 5, that gives us 6. The leading coefficient is the number in front of the variable with the highest exponent. So if I'm looking at number 4, the leading coefficient of 12x squared plus 15x cubed minus 8x minus 28 would be 3. And that comes from being the number in front. Oh, no, excuse me, back up. It wouldn't be 3, it would be the number in front of that x to the 3rd, which would be 15. So a coefficient is a number that is out in front, and the leading coefficient is the number out in front of the variable with the highest exponent. So our variable with the highest exponent is the x to the 3rd term. There's a 15 in front of that. 15 is our leading coefficient. So we want to rewrite polynomials always in standard form, and polynomials are in standard form when the terms are in order of the highest exponent down to where you don't have any, or the constant term. So number 5 asks us to rewrite the polynomial in question number 4. So we want to rewrite 12x squared plus 15x cubed minus 8x minus 28 in standard form. So remember, you're going to go highest exponent, which we said was the 15x to the 3rd. Then we've got a 12x squared. Then we have a negative 8x, and we have a negative 28. So notice that we reordered all of the terms so that our exponents went 3, 2, 1, 0. All right, so finding coefficients of polynomials. So coefficients are the numbers in front of the variables. So in number 6, it asks us to rewrite the polynomial in the form ax plus by plus c and identify what a, b, and c would be. So we've got 8 minus 1/3 y plus 9x. So they want us to rewrite it so that we have our x term first. So when we look back at our problem, 9x is our x term. So we're going to write it 9x first. Then we want our b term. Our b term is negative 1/3 y. And our c is our constant. It has no variable with it. So we're going to put our constant that has no variable with it at the end. So that's a positive 8. So we want to identify our A, our B, and our C. So our A will be 9, our B will be negative 1/3, and our C will be 8. Multiplying binomials and adding and subtracting polynomials. So if you need to multiply binomials, you're going to use a box. And so when we do the box, notice that you've got your two sets of parentheses not separated by a plus or a minus. And so when you see two sets of parentheses side by side, that means that you are multiplying. And so when we multiply, we're just going to multiply using a box just because it makes things a little bit easier to organize. So we're going to start by drawing our box. And you may do this with distributing each of the terms in the first set of parentheses to each of the terms in the second set of parentheses. It's exactly the same process, just drawing the box just makes it easier to organize. So we're going to start with x and negative 4. The second set of parentheses had an x and a 2. So now we're going to multiply inside the box. So it's always outside times the top. So we're going to say x times x. And x times x will give us x squared, because remember, when we are multiplying like bases, we're going to add our exponents. That's an exponent of 1, that gives us an exponent of 2. The next box is going to be outside times the top, so x times 2, so that'll be 2x. Bottom row, outside times the top, negative 4 times x, negative 4x. And last box, negative 4 times 2, negative 8. So then we're going to rewrite it. X squared, taking everything out, x squared plus 2x minus 4x minus 8, and put together our like terms, which are going to be our positive 2x and our negative 4x. And so that's going to give us x squared minus 2x minus 8. Okay, so on number 8, we've got 2x minus 5 times 2x plus 1. So we're going to draw our box. We're going to put 2x and negative 5 down the side and 2x and positive 1 across the top. So 2x times 2x, 2 times 2 will give us 4. X times x will give us x squared. 2x times 1 gives us 2x. Negative 5 times 2 gives us negative 10x. Negative 5 times 1 gives us negative 5. So we take out all of our terms, 4x squared plus 2x minus 10x minus 5, and put together our like terms, 2x and negative 10x, to give us a final answer of 4x squared minus 8x minus 5. Number 9 and number 10 are a little bit different because now we're multiplying a binomial times a trinomial. So we've got 2 terms times 3 terms. Number 10, we've got 3 terms times 3 terms. So in number 9, when we draw our box is going to have to be a little bit different because this time we've got 2 terms on the side and now we're going to have 3 terms across the top. So we're going to draw a little bit bigger box. So when we separate it, because we have 2 terms times 3 terms, we should end up with 6 boxes. So we're going to put 3x and a 6 down the side, and across the top we're going to put a 2x squared, an x, and a negative 1. In our first box, we're going to say 3x times 2x squared. So 3 times 2 gives us 6. Remember, we add our exponents when we multiply like bases. So this x has an exponent of 1, that x has an exponent of 2, so we're going to say x to the third. Next box, 3x times x gives us 3x squared. The box beside that, 3x times negative 1 gives us negative 3x. Bottom row, outside times the top, gives us 12 times x squared. Next box, 6x. Last box, negative 6. Everything comes out, and then we're going to put together our like terms. Okay, so when we do our like terms for this problem, we have 3x squared and 12x squared. Then we have negative 3x and positive 6x. So our final answer is going to be 6x cubed plus 15x squared plus 3x minus 6. Number 10, 5x squared minus 2x plus 1 times x squared minus x plus 3. We're going to draw a 3 by 3 box for this one. So we're going to end up with 9 boxes inside. So 5x squared, negative 2x, and positive 1 will go down the side. X squared, negative x, and positive 3 will go across the top. So we'll have 5 times 1x squared, which will give us 5. X squared times x squared will give us x to the 4th. 5x squared times negative 1x will give us negative 5x to the 3rd. 5x squared times 3 will be 15x squared. Bottom row, negative 2x times 1x squared will give us negative 2x cubed. Negative 2x times negative x will give us positive 2x squared. Negative 2x times 3 will give us negative 6x. 1 times x squared is x squared. 1 times negative x is negative x. And 1 times 3 is 3. Everything comes out. 5x to the 4th minus 5x cubed plus 15x squared minus 2x cubed plus 2x squared minus 6x plus x squared minus x plus 3. Combine your like terms. So you've got a 5x cubed, negative 5x cubed, and a negative 2x cubed. You've got a 15x squared, a positive 2x squared, and an x squared. And then you've got a negative 6x and a negative x. So your final answer will be 5x to the 4th minus 7x cubed plus 16x squared minus 7x plus 3. Actually, that's going to be 18x squared. 15x squared plus 2x squared is 17x squared plus 1x squared is 18x squared. All right, number 11, x plus 5 to the second power. So remember that second power means we have this 2 times. So we're going to draw our box. We've got a 2 by 2, so we're going to have 4 little boxes. X times x is x squared. X times 5 is 5x. 5x here, and a 25 here, 5 times 5. Take them out. X squared plus 5x plus 5x plus 25. Put together your like terms. X squared plus 10x plus 25. Number 12, x plus 5 to the 3rd. X plus 5 to the 3rd means you've got x plus 5 3 times. Now, the good news for us is we've already done x plus 5 times x plus 5. And we know that that is x squared plus 10x plus 25. But we still have to multiply that by another x plus 5. So now we're going to do a 3 by 2 box. So we've got an x squared, a 10x, and a 25, and across the top, an x and a 5. X squared times x is x cubed. X squared times 5 is 5x squared. 10x times x is 10x squared. 10x times 5 is 50x. 25 times x is 25x, and 25 times 5 is 125. So now we are going to combine our like terms. And you can take these out if that makes life easier on you. But your final answer would be x cubed plus 15x squared plus 75x plus 125. Last two problems have to do with distributive property. So number 13 says 8 times 4x squared minus 10. So we're going to distribute this 8 to each piece that's inside. So 8 times 4x squared will give you 32x squared, and 8 times negative 10 gives you negative 80. On number 14, x squared times 7x plus 2, we distribute x squared times 7x and x squared times 2 to get 7x cubed plus 2x squared.